Today, we're going to introduce you to the essential steps for the successful calibration of a non-automatic weighing instrument, better known as a scale. Each scale has a resolution corresponding to the smallest perceptible change of its indication, and a maximum capacity that corresponds to the highest value it can measure. Beforehand, the operator must follow a checklist to perform the calibration in the best conditions. He must check that the scale is properly leveled, ensure its general state, e.g. the cleanliness of the weighing pan or that the display is readable. A stabilization time must be respected after the device is switched on, and the ambient conditions have to be controlled. For the mass standards, there are several classes defined by the international recommendation OIML R111-1. They are divided into three categories. The classes E, F and M. Weights of Class E have the best accuracy. In order to be able to calibrate a scale, the operator must have mass standards, with a class adapted to the specifications of the scale. Indeed, a scale with a resolution to the nearest milligram will have to be calibrated with Class E or F weights, depending on its maximum capacity. The operator, equipped with weights adapted to the scale, here of Class E2, will be able to start the calibration by checking the linearity of the scale. In addition, he has a THB sensor, thermohygrobarometer, allowing him to measure the ambient conditions. He places the weights gradually on the weighing pan in order to cover the entire range of the scale. To determine the accuracy error of the scale, the value without and with the weights must be taken into account. The recommended calibration program consists of 4 measurement points: 25%, 50%, 75%, and 100% of the range. These points are always adapted to the use of the scale. The next step is to carry out an eccentricity test. For this purpose, the operator uses a weight with a value of 1/3 of the maximum capacity. First, he places it in the middle. In a second step, on the 4 sides of the weighing plate at well-defined points. It is recommended to carry out this eccentricity test on a half measure between a corner and the middle of the plate. The determination of the eccentricity allows us to define if the measure is carried out in a homogeneous manner over the entire surface of the plate. It can be omitted depending on the customer's use of the scale. The repeatability of the scale must also be taken into account. For this purpose, the operator uses a weight with a value of approximately 1/2 of the maximum range. Then he carries out at least 5 successive measurements while taking care to note the value without the weight and with the weight. This is more commonly known as the repeatability test. Sometimes with the purchase of the scale, a weight is supplied in order to carry out intermediate checks between the 2 calibrations. This weight can be calibrated by our laboratory using our comparators, with an accuracy for mass calibration up to Class E1 under ISO 17025 accreditation. To conclude, a calibration certificate is sent to you. The uncertainty provided is the result of several uncertainties relating to the density of the air, the eccentricity of the scale, the repeatability of the scale, mass standards convection, mass standards used for calibration, the resolution of the scale, and many other components that may affect the calibration result. A declaration of conformity to a specification or standard can be provided with the calibration certificate. On request, ILNAS laboratories can perform an on-site calibration of your scale under ISO 17025 accreditation.